Next, we're going to go over problem 8. And so this is a graph problem. And I'm going to warn you that this problem is maybe takes a little moment to understand, but the solution is deceptively straightforward. So the following classes define a type of directed graph node and a class traverser, which performs a depth-first traversal of a graph. You are to fill in the definition of graph_util.is ascending so that it tells whether all paths from a given node have labels that are in strictly ascending order. In other words, if let's say we have some directed graph and we start at some node, I don't know, 1, right? It wants to know basically whether all paths possible from this node go in ascending order. And so far, the way I've written it, right, this is true. Because all paths going outward from 1 only hit nodes in ascending order. And in other words, on every single path, we see that every node is less than all of its neighbors. All of its children, or the things that come after it, are greater. Okay, and note that if I were to put in some example like this, right, as soon as we hit this, it is no longer true because we can traverse a path where the child is less than its parent. That's all this question is asking you to do. And there is quite a bit of code to read, but we see that a lot of it honestly doesn't really matter to us. All we see is that we have a node class, right? And we see there's some constructor, we can add edges to it, and we can iterate through all of its children. And so we have this array list called next of all the nodes that it has outgoing edges to, and we can iterate through them. And so, for example, the node 1 would have label 1, and then its array list of next would contain the nodes 2 and 5. Okay, great. We also have this abstract class traverser, which visits things, like we mentioned, in depth first search order. And so what it does is that when you traverse with a given start point, it's going to set visited to be a cleared new hash set. And then it's basically going to do the standard depth first traversal, right? Which is just that it visits the current node and then goes through its neighbors and recursively calls traverse on those. And so this is all we're doing. And our job is to now extend traverser and override visit in order to make it actually not just traverse, but also check for us, hey, are all the paths ascending? And so looking at the skeleton, we see that we define an instance variable ascending, or we define this variable ascending, right? And then we're going to overwrite visit. And then we have this method called isAscending, which is going to traverse the tree and return something. Okay, great. So basically, the question now is, how do we actually implement this? Well, all we'd have to do to see if all paths in the graph are ascending is basically, as we go through, as we do our traversal, and as we visit things, just check, hey, is my label less than all my neighbors? If so, we're good, right? And so as we're traversing, as we go along, just do that during the visit. Also check, wait, are any of my neighbors bigger than me? If they are, then ascending is false, right? We're not ascending. And so we could see that initially ascending would be set to true. But as soon as we find some value where it is suddenly broken, it's false, and it's going to stay false forever. And so initially ascending is true, but then we'll do a visit, right? And if it's false, then we will know. And so during visit, all we'd want to do is say, hey, by the way, for all of my neighbors, or in other words, for node n in node, because we said node was iterable and we could iterate with the neighbors. If n dot label is less than my label, right? Then ascending, sorry, is false. Because we saw that we have a child where the label is less than the parent. And that is all we have to do. Notice we never said you have to use all the lines. Cool. And so is ascending, what it's going to do is it's going to check all possible start points, traverse from them, and if at any point we see a single example where we have a non-ascending relationship, right, where a parent is greater than the child, then ascending is false. It's going to stay false. And so if we make it through all the way and we never enter this, ascending remains true, and that means the whole thing is ascending. And so we can just return ascending. Or I actually think it's going to be chk dot ascending. And that's pretty much it. It's not that crazy. Yeah, I would say that understanding how the problem works is honestly a lot harder than actually writing the code. But if you're able to do this, give yourself a pat on the back. And if you weren't, that's okay, because it was a little confusing.